FlexDex is an enhanced dexterity laparoscopic tool technology for minimally invasive surgery, designed to meet the demands of increasingly sophisticated, minimally invasive surgical procedures, in a package which employs a unique, low-cost mechanical design that does not require any sensors, actuators, or computer technology. Named for the two high-dexterity, wrist-like degrees of freedom at the end effector, FlexDex provides a highly intuitive and ergonomic control of the tool end effector motions, a functionality currently seen only in multi-million-dollar robotic surgery systems. Pictured here, FlexDex comprises an arm brace, rigidly attached to the surgeon's forearm, a tool frame, and a tool shaft. The tool frame provides a direct, one-to-one mapping of 4 degrees of freedom of the surgeon's forearm to the tool shaft and end effector. These degrees of freedom include up-down and left-right translations, in-out translations, and roll along the axis of the tool shaft. FlexDex features a 2-degree of freedom end effector at the end of the tool shaft, which is rotated independently of the other 4 degrees of freedom. The up-down and left-right rotations of the surgeon's hand with respect to his forearm are captured and transmitted to the end of the tool tip as end effector up-down and left-right rotations. This clip demonstrates the one-to-one mapping of the surgeon's wrist up-down rotation to the up-down rotation at the end effector. Similarly, a left-right rotation of the wrist would result in a left-right rotation at the end effector. This novel, independent mapping of wrist to end effector rotations is enabled by a virtual center mechanism. The virtual center mechanism, pictured here, comprises a tool handle, compliant transmission strips, and a pulley-based transmission. The virtual center mechanism is located about the surgeon's wrist and geometrically projects a virtual center of rotation at the center of the wrist, where a traditional joint could not be located. With this unique configuration, the FlexDex tool ensures that when a single rotation is needed at the end effector, the surgeon simply provides an analogous hand rotation at the tool input. Altogether, FlexDex maps 6 unique degrees of freedom of the surgeon's wrist and arm to the tool tip. This highly intuitive, one-to-one mapping between the surgeon's motions at the tool input and the end effector motions at the tool output makes FlexDex a natural extension of the surgeon's forearm and hand. The following videos emphasize the importance of independent one-to-one mapping of end effector rotations. This clip again demonstrates a simple up-down wrist motion and the resulting motion at the tool tip. Note that the wrist motion is independent of any arm motions, and the tool requires no external reaction forces to rotate the end effector. For comparison, a commercially available enhanced dexterity tool is shown. Without external reaction forces provided by a surgical port, wrist motions do not actuate the end effector. When supported by a surgical port, a simple wrist motion produces both end effector translations and rotations, a complex and unintuitive output. Here, all 6 degrees of freedom of the FlexDex are demonstrated. Up-down and left-right translations, roll along the axis of the tool shaft, in-out translations, and finally, up-down and left-right rotations at the end effector. Again, the commercial tool is demonstrated to illustrate these same motions: up-down and left-right translations, roll along the axis of the tool shaft, in-out translations, and up-down, left and right rotations at the end effector. Producing simple rotation at the end effector requires a complex input from the surgeon's wrist, arm, and shoulder. These unintuitive motions also rely on large reaction forces at the surgical port, which can damage local tissues in a patient. This novel, minimally invasive surgical tool design paradigm, and the resulting proof-of-concept prototype of the FlexDex presented in this video establishes, for the first time, the feasibility of achieving enhanced dexterity, intuitive and ergonomic motion control, and force feedback in a simple mechanical tool. FlexDex, with its intuitive actuation, could reduce the steep learning curve currently associated with intricate, minimally invasive surgery procedures, ultimately allowing for improved patient care at reduced costs. We envision that upon appropriate product development and refinement, FlexDex could evolve to be a highly functional and affordable technology platform for laparoscopy, endoscopy, and other medical applications which require manual tool steering.